Folks, welcome to the very first episode of the series where you submit your scripts for me to roast you in my humble prison cell. I still don't have a name for this, so if you have any suggestions, put them down in the comments below. But before we start the video, I just want to quickly mention that I still have a few tutoring slots open, so if you want me to help you achieve your dream grades, then use the first link in the description down below. Otherwise, like the video, subscribe, and let's dive right in. Oh man, this can be a good one, chat. Okay, so we've got our subscriber who will remain anonymous as per their request. So if you want to follow along, this is the 9709 paper 12 February March 2025 pure 1 maths for CIE or CAIE if you will. So we start off with question number 1, and number 1 is a standard discriminant question. Like I don't know how many times I've said this. You are always going to get a discriminant question in all your papers, so just make sure you're comfortable with discriminant question because it's an easy 4-5 marks once you understand it. And to be honest, bro cooked, got all 4 marks straight. So in this situation, we've got the curve and the line do not meet. So that means b squared minus 4ac is less than 0 because we have no real solutions, right? And so you just take your equations, equate them together, reduce to a 3-term quadratic. Once you get there, you then use your discriminant substitute and simplify. You get a quadratic inequality, solve the inequality, and you get your answer. So that one was pretty straightforward and bro cooked. Then we go on to question number 2. Right, so this one starts off with part A. If you read the question, you notice that here we are looking at, it's probably going to lead into some sort of differentiation, right? Because we're talking about a minimum point. And the first thing that should come to mind, whenever you see minimum point, the first thing that should come to mind is dy dx. At a minimum point, at any stationary point, dy dx is equal to 0. This is the first thing that should come to mind. Okay. And so here we are told to find the gradient of the curve at a point P. So we've got this point P here and we need to find the gradient there. And so what bro did, which I respect, anytime you see a minimum point, just differentiate. Even if you don't know what you're doing, just differentiate. You get marks for that. So bro found dy dx, and dy dx ended up being 4x plus 5x to the negative 2. Then the next step, of course, since we are looking for the gradient at P, we're essentially just looking for the gradient of the tangent to the curve at the point P. So we know that at P, x is 1, so substitute x with 1 in your dy dx, and you get the gradient of the curve at P. Then we go on to part B, a 3-mark question, and bro did not cook. So here it says find the coordinates of M. So we know that M is a stationary point, it's a minimum point. So what's the first thing that should come to mind when you see a stationary point or a minimum point? dy dx is 0. Like bro literally did the hard work in part A. So simply what you have to do in a case like this is you're just going to take your dy dx, which is our 4x plus 5x to the negative 2, and then you equate that to 0. And you solve that. You solve the resulting equation. So you're going to have 4x plus 5 over x squared is equal to 0. I've written the 5x to the negative 2 as 5 over x squared, right? Because it's always easier to deal with positive powers. And at this point, you can just multiply through by x squared so that you've got 4x cubed plus 5 is equal to 0. And at this point, it should be pretty straightforward how you solve for x. If it's not, then something is wrong. But anyways, that's literally what bro had to do here. I'm not sure why bro struggled, because here, if we try to inspect what bro is doing, so here they substitute, they go to the original equation and then they substitute x with 1. That's just gonna give you 9. It gives you 9. So that's just going to be what? Whoa, chat. Wait, hold up. 4 plus 5 is 9. Oh, the substituted x. Yeah, so for some reason here, okay, so this is the equation of the curve, but then bro goes on to say that y is equal to, this looks like the dy dx, right? This is the dy dx and substitutes x here and gets 9. This is the same 9 that you get here. So this shouldn't be y. This is still dy dx. So what you were supposed to do here instead was to use your dy dx like I explained here. Dy dx is 0. First thing, minimum point dy dx is 0. I don't care what you do from there onwards, but just write that dy dx is 0. It will eventually make sense. You have to use that some way, somehow. Then on to number 3. Number 3, very, very, very well done. Very executed, very, very well. So we've got a binomial expansion question. And for these questions here, you had to expand fully. For these questions, use your binomial expansion formula. It's given in the MF19, so you don't have to memorize it. It's literally just substituting into a formula. It can't be that hard for 4 marks. Like, that's an easy 4 marks. You should be getting that every single time. So yeah, they substituted into the binomial expansion formula, simplified the coefficients, and ended up with the correct full expansion. Then part B was hence determine the coefficient of x squared in the expansion of that times that. So for this one, it is a bit tricky, but given that you actually have the full expansion, it shouldn't have been that difficult. Because what you do is you replace this bracket here with its full expansion, and they did that. So fair play. And then what you want to do after that is, we are interested in the coefficient of x squared. So you need to find the terms that when multiplied together will give you a term in x squared. So what I mean by that is, if we look at our 2 brackets, if I multiply this x squared here by 216, we get a term in x squared. And in fact, they did that. It's just that they expanded the whole thing, right? And you can see we've got this 216x squared. And then the other term in x squared is going to come from 5 times negative 96x squared, which should give you this negative 480x squared. So those are the only 2 things that we're interested in here. Take those 2, add them together, and they give you the coefficient of x squared. So you don't even have to expand everything. Just figure out the terms that you want, take those and put them together, and that should give you the answer. Number 4 was chaotic, because so for number 4, this is a circular measure question, and we are given what looks like a triangle and some sectors. And my biggest concern here is that the question says find the perimeter. And in the solution, I'm only seeing area. So straight away, I'm concerned, because we're looking for perimeter. Perimeter is the distance right around the shape. It's not the area. So here, what you want to be doing, and also maybe let me highlight the shaded area because it's not actually shaded. Yeah, the shaded region is bounded by arc CD. So this is arc CD, and the line segment CA. CA would be this. AB would be here, and BD. So this would be our shaded region. So whenever you see perimeter, think distance right around the shape. You want to walk around the shape. Area should not even be included here, unless maybe you're given the area already and you needed to find some other variables like maybe radius or the angle. Then in that case, you might use area. But in this case, they've given you everything. All you need to do is to figure out the perimeter. So once you realize the shaded region, what you want to do is figure out which lines and which arcs make up your perimeter. So your perimeter is going to be, they've literally actually just outlined it for you. They say the arc CD, right? It's arc CD plus the line segment CA plus AB plus BD. So that's going to be your perimeter. This is the first expression you should write down, and then the next step, obviously the tricky part, is to figure out how do I find arc CD, how do I find, well, in this case arc CD should be straightforward because you have both radius and theta. But how do I find, actually the only tricky part is finding AB, and it's not even that tricky because you've got all the sides except for this side, the one that you're interested in, and you also have an angle and it's isosceles, so you can either use your sine rule or your cosine rule to help you find AB. So yeah, this whole area, that's a big concern because I think that shows that maybe, I don't know, maybe not too much practice with circular measure, but the question explicitly says perimeter. And part B, you can tell part B is asking for area of the shaded region. And I'm curious, if you calculated area in part A, what did you do in part B? Because part B, yeah, I can imagine, because you would have just repeated the same thing if you wanted area again. And actually, let me check. Is the answer even 10.82? Because it would be hilarious if you wrote the correct answer for part B in part A. This is, nope, never mind. It's wrong anyway, so that's fine, no worries. But it would have been funny if you wrote the correct answer in part A and then didn't write it in part B. But anyways, clearly circular measure is a weakness, a major weakness for you here. You probably need to work a lot more on that. Then number 5, look, this one, I'll be honest, is a pretty challenging question. This series question it's not the most straightforward. We're given that the first term is 5, and we're also given the common difference to be 6. And then the wording here is a bit ambiguous. It says, for this progression, find the sum of all terms that lie between 150 and 400. The best way to think about this one is to say we've got a series. It's starting from 5, right? So you've got 5 and then common difference is 6. So the next term would be 11 plus 6. 11 plus 6 is, oh man, 17. And then 17 plus 6, 23, and so on. Eventually, we're going to get to a point where we get to terms that are maybe, let's say, exactly 150. I'm not sure if it will be exactly 150. Then 156. Then add 6 to that. That's 1. My mental math is terrible. All the way until we get to the term that is equal to 400, and then 406, and so on until we get to the end of our progression, right? So they are saying find the sum of all the terms that lie between 150 and 400. So for us to be able to do this, we need to know the position of this term that is equal to 400. Okay, so we need to know that position, and we also need to know the position of the term that is equal to 150. So let's just say that this is, I don't know, let's just say that this is position 70. And this 150 is in position 50. So what we would want to know is the sum of all the terms that are between 150 and 400. So it would be this 150 plus 156 plus 162 plus all the terms that are here plus the 400. That's what we want. But of course, doing it manually would be tedious. So putting it into a formula, in other words, we're saying the sum of the first, so we're going up to 400, right, which we know is in position 70. So it's the sum of the first 70 terms minus, we want to stop at 150, minus the sum of the first 150 terms. Sorry, not 150, but 50. Right, minus the sum of the first 50 terms, because what then remains is these terms that are between 150 and 400. and that should give you your answer. I know that 70 and 50 are probably not the correct positions, but you'd have to figure out those positions just by using the formula for nth term. So in other words, for 150, yeah, you're saying you know that this term is equal to 150. So un is equal to 150, and you need to figure out what n is. You just use your formula for nth term, which is the a plus n minus 1d. And then that's gonna, you know what a is and you know what d is, so you can substitute, equate that 150, and you get your n, and you do the same for 400 to get the correct positions. Once you do that, you just use your formula for sum to the first n terms. But I'll admit this one was a pretty high order question, so I can understand the challenge. And also I'd say it was worded very ambiguously, very, very ambiguously, almost very intentional by Cambridge to throw you off. And then we go on to number 6. It's like we're going from bad to worse. So number 6, part A. My only problem with number 6, part A, is that it says state the coordinates of the center of the circle in terms of R. So it means that inside of your coordinates, you should have an R. Right, so you should have something that looks like maybe R5. That would make sense because they say it in terms of R. So maybe from what I'm seeing, maybe there was a misinterpretation of the actual question, that you thought the center itself was R because you've written R here. But your answer should have R inside of it. If it does not have R, then something is wrong. And the idea here, let's read the question and see. So we've got a diagram with a circle of radius r, x greater than 0, y greater than 0 for all points on C. The list distance between any point on C and the x-axis. Okay, list distance, that would be this here. This is the list distance, that's 8. And we know that the y-axis, the least distance between any point on C and the y-axis. So the y-axis is here, and the least distance would be that, and this must be equal to 5. And then we also know that this here is our radius, this here is our radius. So you can see that your x-coordinate is just gonna be this distance here, your 5 plus r, and your y-coordinate of the center of the circle is this distance there, r plus 8. That should have been your solution, r plus 5, r plus 8. And then we go on to B. Given that the distance between origin and center of the circle is 15, find the value of r. So yeah, this one, if you don't sketch a diagram, it's going to be very difficult to try to visualize this in your head. So you probably needed to understand, first of all, what the question is asking, because from what I'm seeing here, we've got r is square root of 8 squared. Is that a multiplication sign? Let's see. This is the square root of 8 squared times 5 squared. Yeah, but why are you multiplying though, bro? No, like, even if you're just finding, like, using Pythagoras, right? Do you not subtract or add? I don't understand why there's a multiplication sign. Okay, yeah, for this one, the idea would be, again, just draw the image, draw the diagram, the distance between the origin, so our origin is here, and the center of the circle. So the center of the circle is there. Join the 2 points, that distance is equal to 15. And then once you're here, you just play around with it. Remember the lines that I removed here. We had this part was radius, and then going downwards, we knew that this distance was the least distance from the x-axis, so that was 8 units. And then this is also going to be, if we draw this here, this is also going to be the r plus 5, because that distance is the same as this distance. And all of a sudden, you've got a beautiful right angle triangle, and you can do many, many, many beautiful mathematical things with the right angle triangle. Just draw out the diagram and figure out what to do from there. The posse, yeah, I could tell, bro, did not enjoy this question at all. The point on the circle furthest from the origin is denoted by P. So our origin is this point O, and furthest to the circle, if we keep moving along this line furthest to the circle, it would mean P would be somewhere here. And we want to find the gradient of the tangent to the circle at P, so you just draw a tangent at P. So we'd have our green tangent right there. And I hope you notice that we've got, if I can move this line there, we've got perpendicular lines. We want the gradient of the green line, but we've got perpendicular lines. We don't really have information to find the gradient of the green line directly, but we can use m1 times m2 is equal to -1. And it's not so straightforward, because the first thing that you think is, okay, I have the coordinates of the origin because I know that's 0, 0. And then you'd say, what about the coordinates of P, right? You don't have the coordinates of P. However, you do have the coordinates of the center. So you can find the gradient of this line from the origin to the center of the circle, because that's going to be the same as the gradient that projects onto P. That's just the same line. It's going in the same direction. So the gradient is exactly the same. And once you have that gradient, it's m1 times m2 is equal to -1. So from what I'm saying here, yeah, bro didn't even attempt. They just wrote m is equal to y2 minus y1 over x2 minus x1. Yeah, you don't get marks for just writing down a formula. At least put numbers in there. But I still don't think you'd have gotten any marks for if you had used the wrong numbers. But that was the idea there. Coordinate geometry seems to be a very, very, very weak point. I think anything to do with sort of triangles, sectors, geometry, because I'm seeing that the circular measure was weak, the coordinate geometry was also weak. So it seems like there's a very, very strong gap, big gap there that needs to be closed. So yeah, maybe work on that. Then number 7, part A. This is a trig question. Pretty much a trig identity. Show that 3 tan squared theta plus 5 sine squared theta is identical to 8 sine squared theta minus 5 sine to the 4 theta of 1 minus sine squared theta. Okay, so you picked the left-hand side, 3 tan squared plus 5 sine squared, and then, very, very well done, you took tan squared theta, and you used the identity that this is the same as sine squared theta over cos squared theta, which is perfect. Love that from you. And then where do we go from here? Because it looks like this is where it all went downhill. So we've got 3 sine squared theta. Okay, so you use the identity cos squared theta is identical to 1 minus sine squared theta. Here. Alright, that's fine. And from here, yeah, from what I'm seeing, you are genuinely trying to break mathematics, because it looks like you're trying to do some sort of cross multiplication. But you can't do cross multiplication on the same side. They kind of have to be on the opposite side of the equal sign for you to cross multiply. And because we're dealing with identities where you're forced to work with one side, you can't even do cross multiplication to begin with. So yeah, from there it went downhill. I still don't know how you ended up with the correct right hand side. Let's explore this and see what happened. Okay, so somehow we ended up here, And then we've got 3 sine squared theta plus 5 sine squared theta multiplied by that. Okay. And this is all divided by 1 minus sine squared theta times 5 sine squared theta. Okay, so you expand the bracket, and then yeah, there's some witchcraft that happened here, because I can see it in 3 plus 5 to get your 8 sine squared theta, and then you've got your minus 5 sine to the 4 theta. But what happened to this 5 sine squared theta in the denominator, because it just seems to have disappeared. So yeah, this went downhill when you tried to cross multiply. But if you hadn't, what would I have done instead? Usually for trig identities, what you want to do, in this case, they chose to work from the left-hand side moving to the right-hand side. I want you to notice that on the left, we've got 2 separate terms, right? So, and on the right, we only have 1 single term. So once you eliminate the tan using this identity, my next thought would be to combine my 2 terms so that I have 1, because I know that I'm trying to move towards 1 term. So you'd combine your 2 terms, and then from there just try to figure it out. And yeah, don't cross multiply when you're dealing with the same side. Part B, hence solve the equation. Okay, so here we've got 3 tan squared theta plus 5 sine squared theta is equal to 9. Okay. And so this word is very, very important, hence. So what it means is that you're supposed to use information from a previous part of this question to help you in solving this question. So whenever you see them saying hence, they're saying you've already done the dirty work in part A. So just use the solution you got in part A or some idea you got from part A to help you start from the middle and not from the beginning. So in this case, the application of hence, anytime you have identities, is that they want you to use the other side of the identity. So in this case, you will notice that this right-hand side of the identity only has sign. So it will always be easier to use this side, because when you're trying to solve trig equations, you want to reduce to have only one trig function. So you don't want to have both sine and cos, or sine and tan, or cos and tan. You just want to have one, either just completely sine or completely cos, because that will make your life a lot easier. So in this case, what you're supposed to do is to say, instead of us having our 3 tan squared theta plus 5 sine squared theta, this left-hand side of this equation, I'm now going to rewrite it as 8 sine squared theta minus 5 sine to the 4 theta over 1 minus sine squared theta, because in part A, I proved that these two things are the same. So that's why hence solve that. And yeah, from there, you would simplify, end up with some sort of something that I notice here is be careful. Anytime you take a square root, please, it is plus or minus. Anytime you take a square root, put plus or minus. So here where we've got sine squared theta is equal to 3, it would reduce to, assuming this was correct. We know that it's not correct. Why am I assuming it's not correct? Okay, assuming it is correct, you want to say sine theta is plus or minus root 3. So from here, you end up with 2 separate equations. Either sine theta is positive root 3 or sine theta is negative root 3. Okay, so those are the 2 equations that you would have anytime you take a square root. This applies. So even if you're just solving a normal algebraic equation with x, anytime you take a square root, it's plus or minus. If you don't put the minus, you don't include the negative solution, you lose a solution. Okay, so trig identities, I know that they're a bit challenging for most people. The only way to get better at identities is to do a lot of identities and to spot some of these patterns. The general idea with identities is you're taking one side and obviously trying to move to the other side. So I want you to notice the small things that make the sides different. Because one of the first things I notice here is that on the left hand side, we've already got our, let me erase this, it's getting a bit messy. On the left hand side, we already have our sine squared theta, which is also common on the right hand side. But the difference is that I've got tan squared theta on the left, but I've got sine to the 4 theta on the right. So if I'm moving from left to right, I'm thinking, okay, I'm probably going to have to rewrite tan squared theta so that somehow it changes to something in terms of sine. That's the first thing that I notice. And so you then use this identity. And then the next thing that I notice is that I've got two separate terms on the left-hand side, but on the right, it's one combined term. So it's those small things that you want to look out for when you're trying to prove identities that help you actually see which direction to go in. But yeah, you just get the right identities by doing more and more of them. Then this one we have to give pro his flowers because they cooked this question. 8 part A, geometric progression, find the common ratio. So here we're given that the second term is negative 20 and sum to infinity is 160. So you create two equations. You really should be putting an equal sign here, but it's fine. You know, you cooked, so we'll ignore that. So we know that the second term is negative 120. So that means AR is equal to negative 120 using the formula for nth term for a geometric progression, which is UN is equal to AR to the n minus 1. Okay. You're also given that the sum to infinity is 160. So you use the formula for sum to infinity. This is again provided in the MF19. And then you substitute, you end up with two equations, solve those two equations simultaneously, and you find your common ratio. And then here, it looks like you end up with two common ratios, so you have to find a reason to reject one of the common ratios and pick one. And you argue that as second term is negative, then our R must be negative 1 over 2. And the examiner said ignore subsequent working. So ISW means ignore subsequent working, which means that you've already cooked, right? There's no need to add the spices. Like, it's good, bro. Like, you've done enough. It's fine. So they just ignore that extra working. But, you know, it doesn't hurt to explain what you're doing. But now, you dealt with that question pretty well. Part B now, find the sum to infinity of the remaining terms of the progression. And we're given that the first 9 terms of the progression are now removed. So if the first 9 terms of the progression have been removed, it means that the first term of this new progression must have changed. Because if we had, do we know what A was? They calculated A here to be 240. So A is 240, and then here we're going to have, you'd get your next term, right? Get your second term, you get your third term, you get your next term all the way up to, let's say maybe the 10th term is like, let's say it's 108. So we've removed the first 9 terms. So your progression now starts here at 108. So you've got this new A. Your A is now the 108, or whatever A is once you remove the first 9 terms, you need to figure that out. But that was the trick here, because it seems like you just used the original A and calculated sum to infinity, which was the mistake. Okay. And then we go on to a bit of, looks like differentiation mixed with integration, number 9. So for part A, use the expression for the second derivative to determine whether the stationary point is a maximum or a minimum point. Okay, very straightforward. Just substitute x with your x coordinate at your stationary point, which in this case is half, and you got that the second derivative at x is half is 56, which is positive, greater than 0. So this means that we've got a minimum point. Perfect. Then 5b, that's a hell of a question. Find the equation of the curve, 7-mark question. So yeah, this is long because you're going to have to move from your second derivative to the first derivative to the equation of the curve, which would be y equals to, that's what we want. And to do this, you're having to integrate, right? Because that's how we move from the derivative to the equation. So from the second derivative, if you integrate once, you get to the first derivative. If you integrate again, you get to the original equation. So you did that first step. I can see you integrated your second derivative and you got this answer, which looks correct because you got your B marks. Your B1 means stating something that's correct. So if it's B1, it means that you've stated the correct thing. You don't really need to show working, you just need to show the correct thing. That's a B mark, so state the correct thing. M marks, those are method marks. You get those if you use the correct method. But if you use the wrong method, you lose those marks. And then A marks, those are accuracy marks. So after you carry out a method, right, a method mark, you might use the wrong numbers, but as long as you've used the correct method, you get those method marks. But after that, if you get the correct answer, then you get an accuracy mark. So that those are the A marks that you're seeing. So if it's not accurate, then you don't get the accuracy mark. So in this case, for dy dx, what was supposed to happen is that, yeah, I don't know why your constant just disappeared. You're supposed to have a constant still here, right? So we need to evaluate this constant before we can proceed. That was the catch. And earlier on in this video, I say the first thing that should come to mind when you see a stationary point is dy dx is equal to 0. Because we were given that we've got a stationary point at half 9. So we know that when x is equal to 1 over 2, dy dx is 0 because that's a stationary point. So you were supposed to use dy dx is 0 and x is half to help you evaluate this constant c. You substitute your x with 1 over 2 and you substitute dy dx with 0 and you solve for your constant and you'd get that constant. Once you know your constant, you integrate a second time to get the equation of the curve y is equal to that, and you're going to get another constant of integration, and this time for that constant of integration you just use the original coordinates of this point half 9 because that's a point on the curve. Okay, and so yeah, once it kind of went downhill once you lost that constant. But you did get some method marks because, again, remember method marks, if you use the correct method, regardless of whether your numbers are correct, you get those method marks. So you integrated dy dx and you got that with the new constant, right? And so you got method marks for integrating and you got method marks for trying to evaluate this constant with the 1 over 2, 9. So you had the idea, but it's just dropping the first constant that costs you there. And to be fair, it's a bit of a tricky question because it's not every day that you're integrating from the second derivative to go to the first derivative and then from the first derivative to go to the equation of the curve. But yeah, the constant costs you. Oh man, number 10. Number 10. We're looking for the area of the region A. So A is this whole region here. Right. So already I can see that the formula that you're using here, the integral of pi y squared dx, that is the formula for volume of revolution. And you're saying that this is through the y-axis. In fact, it's supposed to be, if it's through the y-axis, you'd have dy. So it would have been your volume is the integral of pi x squared dy. if you wanted to rotate around the y-axis, but we're not even rotating at this point, so there shouldn't be a pi at all. You overcomplicated this. So all you were supposed to do is to integrate with your limits being 0, this point, and then we need to know what the x coordinate is here at the point P. Do we know that? It's 7. Yes. So 7, 0. So you're just integrating this curve that we have over here from 0 up to 7, and that should give you your area of the shaded region. So as soon as you bring in this pi, you're already thinking of volume of revolution. So it's going to, you overcomplicated it. You didn't need to have pi. You didn't need to find y squared. You just were supposed to integrate your curve, limits 0 to 7. So yeah, and it looks like there was a domino effect part B, because you did the same thing, part B's area of region B. So again, this is area, it is not a volume, so we shouldn't see pi. If it was volume, then fair enough, but we shouldn't be seeing pi. And in this case, to get area of region B, you want to create an expression, right? You want to say area, maybe let me leave it like that. You want to say area under our line. I'll highlight this line in blue. It's going to be area under line minus area under curve. Under curve. Because if you find the area under the line, it's going to be this whole area here. But we want to subtract area A, which is what we would have calculated in part A, so that we only end up with region B. And so I guess the reason why it would carry the 5 marks is because we don't know the equation of our line, right? So we need to find the equation of that line. All we know so far is that this line is a tangent to the curve at P is 7, 0. Okay, so we would need to find the gradient. Since it's a tangent to the curve, you should think dy dx. So we need to find dy dx of your curve. So you differentiate this, get your dy dx, and then we know that it's tangent at P0, 7, 0. So you substitute in your dy dx, substitute x with 7, and this is going to give you the gradient of the tangent. Once you have gradient and a point, then it means you can find the equation of the line. And once you have the equation of the line, you can, if you want, you can integrate, but you can also just notice that this is a triangle, right? So you can just find the coordinates of Q there. And once you know what this y coordinate is at Q using the equation of the line, then you just find the area of the triangle and then subtract area under the curve, and that should give you B. So I think you were confusing between volume of revolution and area of shaded region. So just make sure to go over that. And oh, the thing is, you first learn area under the curve before you learn volume of revolution. So that's what's confusing me. And the first thing that's supposed to come to mind is area under the curve. I'd be more surprised if you didn't know volume of revolution, right? That would make sense, like, because it's a more complicated topic, but not knowing area of a shaded region is, I don't know, maybe, you felt a bit of pressure in the exam and that got to you. I'm not too sure what happened there, but definitely the more common integration problem is the shaded area under the graph, right? And not so much volume of revolution. So you should be more comfortable with area under the graph. Then I believe this would be the last question, and it's a functions question. Okay, so here we've got two functions, f and g, and we've got a lot of constants in here. We've got c and we've got k. Okay, no pun intended. All right, so they want us to show that the gf of x is equal to 8x squared minus k minus 1. Okay, so you replaced x with f of x, all right? And you substituted this into g, so our f is 4x squared minus c. So now going into g, you're replacing this x here with 4x squared minus c, so it becomes 2 times 4x squared minus c plus k. Perfect, very well done here. And the trick now, comparing what we want and what we have, you notice that the difference here is that they've got minus 2c instead of, or they've got negative 1 instead of the minus 2c that we have. So we need to find a way to get rid of the c. And that's where this additional information comes in. You substituted c with 3k plus 1. That's not necessarily how you should use that. I think there's two ways, from what I'm seeing, there's two ways you can approach this, right? Because we want to rewrite c in terms of k. So we need a relationship between c and k. And there's two ways, given the information they've given you, is you could either find g inverse using g of x, find g inverse of x. Okay, and then once you have that, you're just going to substitute x with 3k plus 1. And whatever result you get, you equate to c, and you can then substitute that in there. Or the second idea that you can use is going to be, let me write it as f inverse of f of x is equal to x. An inverse function cancels out the original function to leave us with x. So the way you'd have used that idea is to say, here we've been given that g inverse of 3k plus 1 is equal to c. If I just say g on both sides, right, apply g to both sides, because what you do on one side, you do on the other side. You can cancel out g and g inverse, because an inverse function undoes the operations of the original function, so they cancel each other out. So you'd end up with 3k plus 1 is equal to g of c. And you know what g of x is, so replace this x with c. So you end up with 3k plus 1 is equal to 2c plus k. And from here, I'm sure you'll be able to rewrite c in terms of k. So you could have done it the way of finding the inverse and then substituting, or you could have done it using this idea of inverse functions cancelling each other out, which I think may have been a bit simpler. Then we go into part B. What happens in part B? Part B is transformations. Yeah, transformations they're a nightmare. So here we have that the curve with the equation y equals 8x squared minus k minus 1 is transformed to the curve with the equation y equals hx. And then, okay, by the following sequence of transformations, and we've got translation of 2, 3 stretch in the y direction by scale factor k and reflection in the x-axis. Yeah, you didn't even attempt. Yeah, no, I understand. Transformations, very difficult to grasp. So what you want to do is you want to obviously take it step by step, right? We can start with the very first transformation that we have, which is the translation. But I want to focus on the translation in the x direction first. So if you've got y is equal to f of x, a translation in the x direction by 2 units looks like this. It's x minus 2. That's going to be a translation in the x-axis by positive 2 units in the x direction. So it means you're going to want to substitute this x in your function, because that's representing our f of x, with x minus 2. So you'd have then said 8x minus 2 squared minus k minus 1. So that would have been the translation in the x direction by 2 units. And then you continue taking on your transformations. The next one will be translation in the y. So if you've got y is equal to f of x, translation in the y is f of x plus whatever constant you've added. In this case, we've added 3, so plus 3. So it means if this here is our new f of x, you just add 3 at the end of that function, right? So you then end up with a new function. I'll write it here, 8x minus 2 squared minus k. Then we've got minus 1 plus 3, so that's going to be plus 2. And then we've got a stretch in the y direction by scale factor k. So if you've got y is equal to f of x, a stretch in the y-axis, you're just multiplying your function by the scale factor. So in this case, multiplying f of x by k. If this here is our f of x, it means you're multiplying everything by k. So you put a big bracket here, and this is all being multiplied by k. And then reflection in the x-axis. Reflection in the x-axis simply makes your y values negative. So I'm being a bit lazy here because I'm not writing y equals. So if you reflect something, in the x-axis, you're just multiplying the y values by a negative sign. So if we are saying that y is equal to this whole thing, it means we have to make this whole thing negative. So you have to multiply this whole thing by a negative sign to reflect it in the x-axis. And so this here would be your h of x. Maybe we can expand it, right, and say h of x is equal to negative k times 8, so negative 8k x minus 2 squared, then negative k times negative k, that's positive k squared, negative k times 2, that's going to be our negative 2k. Negative 2k, so this should be your h of x. So you want to understand, for transformations, understand the individual transformations first. And then once you understand those, learn how to apply each individual transformation step by step. And that's how you get comfortable with dealing with these combined transformations. It's just taking the single transformations and then combining them into one. Okay, and then part C, yeah, you really struggled with functions because you got how many marks? 1 mark out of a total of 10 marks for functions. So yeah, it's not easy. Okay, so we've got the range of h given by h of x is less than or equal to 15. So from my calculation here, do we know if k is positive or not? I'm trying to see if we know the sign on k. Okay, we know that k is a positive constant. The reason why I wanted to know whether k is positive or not is because if you look at h of x, we've got negative 8k. Since k is positive, it means that the coefficient, if we were to expand everything, the coefficient on x squared is going to be a negative sign, right? And that's important because it tells us the shape of our quadratic. Is our quadratic like this or like that? Since we're dealing with range, we need to know that. So in this case, because k is positive, it means that this negative 8k is overall going to be negative, which means that when we then multiply by the x squared we get inside there, our coefficient of x squared is negative, meaning that our overall function is going to be the upside down or Z face parabola. Okay, and so we probably have something that looks like this. This is not going to be an accurate sketch. You don't need an accurate sketch for things like these. We know that this point here is going to be 15 because they're saying h of x is less than or equal to 15. So in other words, the maximum point here is going to be 15, or the turning point, we know that y is 15. And that helps us because I'm running out of battery. And that helps us because if you notice h of x, let me rewrite h of x. It sort of looks like a completed square form, right? Our h of x. Ignore the car revving outside. Okay, our h of x, it's in the completed square form, x minus a squared plus b. So we can read off the coordinates of the turning point from h of x to b. Our x value is going to be x minus 2 is equal to 0. So we know that x is going to be 2. And then our y value at the turning point is going to be, it's usually b, right? Because typically it's a, b. And so it's going to be k squared minus 2k, k squared minus 2k. But notice that we know what the y value is at the turning point. We know that it's 15. So in other words, this k squared minus 2k has to be equal to 15. So that's how you then find your k. Equate k squared minus 2k to 15 and solve your quadratic equation. As for c, you would have created some sort of equation for c in part A when you were eliminating your c to get 8x squared minus k minus 1. And that would be the paper. So yeah, there were quite a few topics that you didn't seem as strong with, because we started off with quadratics. Quadratics is very, very comfortable with it. You cleaned that discriminant question. But then we got on to coordinate geometry. You struggled with coordinate geometry. You struggled with circular measure. You struggled with functions, trigonometry. Yeah, could have done better for trigonometry. Series, I think you were actually pretty decent at series because you cleaned that binomial expansion question and you also cleaned the geometric progression question. The 6 marker for, what was the 6 marker about? Yeah, this one's understandable. It was a bit challenging. Differentiation is a bit iffy still. You could have done better because this is basic stationary point question that you need to know that at a stationary point dy dx is 0. That's the main essence of differentiation at this level. Dy dx is 0 at a stationary point. So that was a bit suspect. Integration, very, very questionable. Because the area of the shaded region question, that completely knocked you out. Completely. But overall, it seems like there's some basic understanding or surface level understanding for most of these topics. If I had to give you advice, I would say, I don't know if you're writing again or not, but I would say integration is a topic to focus on because you mixed up area of shaded region and volume of revolution. But I can tell that because you already have some understanding of volume of revolution, it won't be difficult for you to understand the area of shaded region. So just make sure to get clarity on those two things. I think I have some videos on that, so you can just search through this channel and find the difference between area of shaded region and volume of revolution. So that's your main problem with integration. Then moving backwards, differentiation, the main idea that let you down was dy dx is 0. So at a stationary point, dy dx is 0. Then series, yeah, no, that was a high order question. That one is difficult. I don't really blame you for getting that one wrong. Trigonometry, do more identities, try to find patterns between identities. And then I'm moving backwards. Circular measure. Oh no, a lot of work needs to be done on circular measure. You need to do a lot more questions on circular measure because you had a perimeter question, but you were calculating area. So I don't know if that was just lapse in concentration, but it can't be because part B, they're also asking you for area of shaded region. So you had to have realized when you got to part B that something is wrong. I've done something wrong in part B, in part A, if I have to find the area again. So do more practice on the circular measure questions, and coordinate geometry was also the circle question. Coordinate geometry, there was also, very questionable performance here. I mean, to be fair, it's not the most obvious question, but you should at least have an R somewhere here, bro. The question explicitly says that in terms of R, so your answer should have R. And then functions, functions is critical. Functions, the three main topics that hold pure one together, that carry a lot of marks. In this paper, it was unfortunate that integration had like 16 marks. That's unheard of, but integration is usually not that significant. But the three main topics that need to be strong are going to be series. So that includes binomial expansion and your arithmetic progression and geometric progression. So those need to be tight, but you seem to have a decent understanding of those, so that's fine. Then functions. Functions is very, very crucial. So you need to strengthen your functions. Here it came with 10 marks and you were only able to collect one of those 10 marks. So it's very important that you understand your functions. And then differentiation becomes the next one. These are the three pillars of Pure 1. If you can master those three things, you will pass your AS level Pure 1 math. Obviously, you need to know everything because all the topics are going to be somehow included. But if you don't have these three, then you're almost guaranteed to fail your Pure 1 exam, right? So, yeah, functions needs a lot of work because we only got 1 mark here. To be fair, with 3 marks on transformations, and transformations is like one of the hardest concepts to understand in Pure 1. But this question here actually has a lot of inspiration. It took a lot of inspiration from the February-March 2024 functions question. I don't know if I'll post it somewhere here, but you find that the ideas that were tested here, they're the same ideas that were tested in February-March 2024. So it's very interesting that they've taken an idea from the previous sitting, right? The previous February-March sitting, and they've just implemented it directly in there. I haven't really looked at February-March 2024 in a while, so I'm not sure if there are any other similarities, but I'm aware of this one because this question looks very, very similar to the one that came in 2024 in terms of the range part, where you've got h of x is less than or equal to 15, and then you have to find k. And then also the idea of the inverse and the original function cancelling out. That one was applied. That's the first time I actually came across that idea, was in the February-March 2024 paper. So yeah, do past papers, I guess. It prepares you, because if you had done February-March 2024, some of these ideas would have been familiar. Anyways, is there any topic I missed? Quadratics. Quadratics is your strong point. You seem to have a pretty good understanding of quadratics. But the critical topics that I think you need to work on would be functions, coordinate geometry, circular measure, and integration. The other ones, they're somewhat okay. But those 4 that I've mentioned, they're a priority. And yeah, I think we ended here. Maybe in the future I'll make like a PDF summary analyzing your strengths and your weaknesses or something of that sort. But anyways, I hope you guys liked that video, and make sure to comment down below, what do you think we should call this series? And also, if you want me to analyze your script, there's a link in the description down below. It will be the second link, I think. Click on that form and submit your script and you'll be roasted. I hope you guys actually find this useful, because the idea here is not obviously just to criticize you, it's to help you understand the mistakes that you're making and how you can improve on them. And I think a lot of other students would make similar mistakes, so they'll find this type of content helpful. Whereas if I'm just solving a past paper, right, I have like a certain way of solving most questions, so I may not be able to emphasize certain things because I do not approach questions in a certain way. Whereas if we're seeing how a student approaches it, then we can see, okay, that might be a potential downfall, that might be a mistake that they make, and we can learn from that. So hopefully this series is useful, and if you do like it, let me know in the description down below. But anyways, thank you for watching. Goodbye. See you next time.